Once upon a long ago, a man looked up to the sky and saw the stars. His heart was struck by a spark of passion for knowledge. He invented the wheel, tamed the power of wind, steam, electricity, and the atom. He learned that knowledge itself is the ultimate prize. And now, here, in a land where the very air is thick with history, where the echoes of the past meet the dawn of the future, where vision is molded into substance, where like-minded people catch trends, where ideas ignite passion. Let the celebration of science begin now. Pattern recognition and information processing. Embedding the future.
Okay, good morning, ladies and gentlemen. So, the weather quite dry, but I hope that these 3 days you will have a good mood. So to have an exciting keynote speakers, to have sessions, with your sessions, and so we'll have morning session and afternoon session these whole 3 days. Actually, I will not say any words because you had a nice intro video. I would like to say that all of these conferences, starting from 2021, have in the mottos, and this year the motto is embedding the future. Actually, it's quite plain word. I know that you know about this terminology because it comes from AI, but it also reflects what we have in the pattern recognition information processing, what we actually bring into life to our everyday life. So no more words from me, and I hope that we will have a good start. And now, let the show begin.
Machine and deep learning, computer vision and signal processing, artificial intelligence and neural networks, cloud computing technologies, and more. Pattern recognition and information processing, embedding the future.
Opening the conference, I would like to give a floor to our conference manager, conference chairman, Professor Alexander Tuzikov. Please, you have the floor now. You may.
Dear colleagues, it's very nice to see you at our conference. You see that it's already 70 conference organized here in Minsk, in Belarus. We started this conference many years ago in We started this conference many years ago in 1991, so more than 30 years ago. And that time, first it was the first Soviet Union conference on pattern recognition and image processing. Then in 1993, we continued, and it was already like international conference organized in Belarus, and we three organizations in Belarus. United Institute of Informatics Problems of the National Academy of Sciences of Belarus, Belarusian State University, and Belarusian State University of Informatics and Radio Electronics. We organized this conference every 2 or 3 years, and every of these institutions for the main institution for the conference. For still, this conference was very popular here in Belarus, and even we organized several of such conferences under the umbrella of the International Association of Pattern Recognition. And this conference is organized by the United Institute of Informatics Problems, and the previous one was organized by Belarusian State Universities. We have got many applications and many reports for this conference, about 200, and 102 were selected for the conference programs. But the main idea of our program committee and also of the organizing committee of this conference to have a conference, one-track conference, just to be able to listen to everybody accepted for the program. And therefore we have a very tough program, and we have not long presentations at this conference. I would like to say 3 types of conference presentation: regular, lighting talks, flash presentations. It was just done to be able to hear everybody of our presenters. The conference is organized in a hybrid mode, so some presentation will be done offline and several will be presented online. It's a normal style of organizing the conference. I would like to say that the topic of this conference covers very important problems in information processing and recognition, and we are lucky that we have also very interesting key speakers at our conference. Today we have 2 speakers, Professor Dmitry Chikrin from Kazan University, Professor Minglei Fu from China, from Zhejiang University of Technology. We have also key presentation for tomorrow, and for the 3rd day, I would like to say the very interesting presentations by Professor Fan and Professor Li from National Defense University in Changsha in China, and also Dmitry and also Sergei Markov will make a presentation, who is now Director of Artificial Intelligence Development at Sberbank in Russia. And Sberbank is in Russia main organization now responsible for artificial intelligence development and everything doing with artificial intelligence. I would like also to thank everybody who contributed to organizing this conference, people who will present their presentations, but also companies in Belarus and in China who contributed much to organizing these conferences and made this conference a reality. So in the program there are the names of these organizations. So I hope that the conference will have a success, and I am very happy to announce that we can open this conference. I would like to also to present the main responsible person for this conference, Professor Sergei Krublikov, who is General Director of the United Institute of Informatics Problems, and duties like umbrella, all this activity was done in our institute. And he is also a co-chairman of this conference. The second co-chairman of this conference is academician Sergei Ablameiko. I would like to give him also the word, and would like to say that he was the first person in Belarus organizing the first conference on pattern recognition of information processing, and due to his activity, these conferences are still organized in Belarus. Besides, he is chairman of the Belarusian Association for Pattern Recognition and Image Processing. Okay, please.
Thank you, Alexander. Good morning, dear colleagues. It's my great pleasure to be here together with you, and it's really we have 17th. Our conference almost 35 years ago, 34 we started, and it's really very good that we continue. And Alexander said about how many people, how many papers we have. I only can tell that we have speakers from 9 countries. Alexei told us. It's also quite good in this, let's say, unstable world at current time. And it's really very good that we can collect here today. And it was pleasure for us that we received around 200 papers, and it's really very, very good. And we are grateful our Chinese colleagues who come here. And really it will be very good, interesting days. And again, thank you very much for coming here, and I wish a very good success, our 17th International Conference. Thank you.
Okay, so ladies and gentlemen, so I would like to say some words for that, last but not least, at this opening session, that we have partners, because actually this conference will not be possible without our general partners. And here also in the audience we have a director of one of the partner. It's a web tech company, and this company is dealing with financial technologies, and so thanks to them we are also organizing here Catherine. And at the evening we will have reception. So all of you welcome, because this reception is organized to another partner called Innotech Solutions. We're dealing with AI instruments in cybersecurity. So currently I would like to turn the conference to the next step, to our plenary session. And again, please, this plenary session will be chaired by Professor Alexander Tuzikov, and he will present the first speaker. Please, Alexander Tuzikov, Professor, you have a floor.
Okay, dear colleagues, because we have a tough program, so it is good to start even a bit earlier than it was planned, because we also planned that several other people will come to the opening ceremony. I mean, the chairman of the National Academy of Sciences of Belarus, but he is busy also with parallel conference, young scientist conference, which is organized in Belarus at the same time. So I would like to announce the first speaker for our conference, Professor Dmitry Chikrin. his presentation is design templates for unmanned ground vehicles and other subsystems. I would like to say that Professor Dmitry Chikrin is Faculty Dean of Artificial Intelligence, Robotics, System Engineering at Kazan Federal University. He is a laureate of the National Zavoysky Physical Award, laureate of the National Engineer of the Year Prize, and published more than 100 articles and conference papers in the field of robotics, telecommunications, and artificial intelligence. Please maybe a talk.
Peter? Opening the colleagues, it's an honor to open a free to 2025, and I welcome you to a program dedicated to pattern recognition and AI at the edge in the field of unmanned transport. I'm the director and founder of Artificial Intelligence Institute of Kazan Federal University. We have a major stake in the rush of direction of intellectual property in the field of unmanned transport of every kind. Today, I will share system view design patterns to ground unmanned transport, from automation levels to universal architecture of automation kit, then walk through the major subsystems from navigation, machine vision, computing, software frameworks, decision-making logic, and finally, a methodology using a vehicle in the loop for simulation. Let's begin. First, already now, levels of automation of unmanned transport. At level 0, the driver alone control vehicle. Level 2, introduce party automation with advanced active assistance. Level 3, conditional automation with basic AI functionality. Level 4, high automation without driver assistance, and level 4 full automation without driver at all. Here, universal structure for automation kits that can scale across every platform. At the edge of the screen, we have passive preservation sensors, active sensors such as lidars, radars, sonars, navigation system, integrate satellites, inertial odometric inputs. At information interaction layer, the sensor inputs to the computational control of unmanned transport systems includes both low-level and high-level automation. Telecommunication subsystem provides V2X, vehicle-to-infrastructure, vehicle-to-vehicle, and more. Multimedia and standard system controller interface with vehicle standard executive devices. First, and probably most important subsystem of every unmanned vehicle is the navigation subsystem. Navigation subsystem consists several major modules. Inertial model would perform fully autonomous driving, odometry, satellite navigation subsystem, and fusion with machine vision. In our approach, we perform fusion of navigation systems, highly focused in inertial navigation, because we have a unique distributed navigation approach what can perform fully autonomous driving for every vehicle without any types of satellite navigation or other supplement systems in the terms of half an hour up to an hour. This is more than enough for fully autonomous driving in almost every condition, in every intentionally mitigating of global navigation satellite systems. Communication subsystem where
In our approach, we have special focus in the work for robustness because often in the territory of Russian Federation, especially in the terms of previous 3 years, we have negative conditions in the field of telecommunications, satellite navigation, radio frequency spectra at all. So our telecommunication subsystems worked in every condition and consists from 4 different units from digital high frequency geodesic stations and up to high performance 5G compatible transceivers, what will perform every in the terms of high power and intended interference of different kinds. About machine systems, we are created and using very interesting approach of machine vision, what are integrated in the one off-the-shelf case. You can see it on this slide. Also, we are using not so computationally intensive visual reconstruction approach, what are also named as Stickler approach. Stickler approach integrates both analytically and computationally finding actors, obstacles, and many types of intended and unintended interference in the field of road for digital unmanned tractor, and work for not so fast computational books. For example, for standard STM32 Cortex M0, we have fully integrated loop of road planning, estimation of obstacles at all. What about algorithms also? Algorithms and subsystems of our software approach. Here we have complex software architecture of different software units, what will perform all tasks for ground unmanned transport. Our architecture is fully universal for every type of ground unmanned transport. In previous 10 years, we have performed more than 20 integration for different unmanned transport from heavy trucks and lightweight passenger cars up to unmanned transportation units. Here we have standard 3-level architecture of computational work because we are specified about each and every function now of digital unmanned transport may be dissected for 3 different layers identically to man conscience. The upper level is similar to man conscience and consists of high-level automation procedures. Middle level is about sub-portions, fast procedures, and the lowest level is identically to reflex layer of man psychology, and here we will detail this in this approach. For example, for each level, each of these 3 levels, we have different computational architecture, different computational units. For low-level computing, we have low performance but high robust Aurix, Infineon Aurix microcontroller for reflexive control. About every solution what should be performed at the time of 1 millisecond. At functions level, we have standard NVIDIA Tegra, also known as Jetson, a computation model, and the middle level subfunctions. We are using high performance Snapdragon or NXP computational units with shared deadline Linux approach for high precision and risk absence timing of performance our procedures. Here we have differentiation, different tasks of automation of unmanned transport for these 3 levels. You can see each and every task for standard standard car on the road. And the last topic, what are specified in our approach, is fully integrate with the logic of planning, control, testing, and the car models itself is vehicle-in-the-loop approach. Via complex modeling every emergency situation, every road scenario, every type of obstacle at all for our cars, for our models, in the also known as vehicle approach. In the such types of installation, what we will model each and every road scenario, what consistently mitigate the risk and could train different scenario for our vehicles. Thank you very much. I try to speak frankly and short.
Okay, thank you very much, Dmitry. We have plenty of time to ask questions, so please.
If anybody has a questions, please. I just start questions and you continue because we have time and we should follow.
So you spoken about automobiles, all right? Or some like flying.
Automobiles, ground unmanned transport.
And do you have in VR already
Demos of all this system which I use, for example, in Russia is what kind of already is the system?
Almost all real installation in Russian Federation consists of approaches what include our intellectual property. For example, each and every news about modern roads in the territory of Russian Federation, M12, M11, and unmanned transport from Moscow to St. Petersburg consist of the trucks with our major partner, KAMAZ. Every type of KAMAZ vehicle, the most types of NAMI vehicles, different types of our heavy industrial partners. For example, in the late 3 years, we have worked with our work strongly with our major Belarus partner, Minsk tractor manufacturer. Consists of our telecommunication, navigation routines, computational works. In the previous 10 years, we have more than 20 full ground installation and relocation, for example, platooning exercises from Moscow to Kazan for heavy trucks in regular transportation.
And how safe are these systems? I mean, how safe just from...
How safe? There is no emergency for 10 years at all. No casualties, no emergencies. We try to perform safe assistance.
Okay, please continue questions. Yeah, please.
Every question pick up the level. Okay.
Do you use any model like
Large language model or maybe RAG approach
No.
or develop?
I understand the question. No, we will perform our approaches when large language models is no one for common using. We are using for machine vision, for example, traditional optical flow control, Stickler approach. For decision logic, we have decision trees, Bayesian and the Schaffer approach, navigation subsystems, integrated classical, numerical evaluation, optical filtering. For our architecture, we are not using large language models, but we are planning to integrate modern RLL in the term of estimation risks and control vehicle in the cases what are not integrated in the standard decision tree. For example, not often scenarios what we may discover on every road. For example, old woman on the high-speed highway. In these cases, we think a large language model may successfully integrate in our decision logic and substantially increase the level of safety and control our unmanned vehicles.
Thank you. And the second question, please. Do you use any real data from real tracks?
Yes, sure. We have a significant amount real data. About 10 years, we have more than tens of thousands real video sensors, footprints, driver model description at all from cameras, Minsk transportation, NAMI, our several partners. We have a significant footprints and significant database for these types.
Okay, please. Additional questions? Okay, please.
Most of your software writing in C, why not Python?
Please repeat.
Most of your software writing on C, yes?
No. C, C++, assembler, some Python, of course, CUDA. We have freeware complex architecture. For example, Infineon Aurix have its own C++ slash assembler dialect. We have complex language infrastructure.
Do you think the C++ or C is more performance than Python?
This is a very difficult question because in the different types of scenarios, no C++, Python you'll be using. For example, for NVIDIA Tegra, also known as Jetson, we should use CUDA simulation, what absolutely different language. In the different scenarios, we have not so high computationally intensively task because our modern computational approach, our modern computational models have a significant edge of performance. So we may use in the different scenarios Python roll times because in Python we may program faster, for example.
In Python faster.
Programming faster. We may programming faster.
Okay, thank you.
Okay, please. Additional questions? Vasily Kovalyov, please hear you. I know you have questions, Vasily, please. Not very high. Oh. Yeah, okay, so I will ask instead of you also a question. But what kind of sensors do you use in your real industry installation? From what kind of sensors do you process the data?
Our central types of sensors is multispectral cameras and distributed inertial navigation units of our own producing. Complementary sensors is ultra-wideband radars, 77 gigahertz, and sonars for low-speed integration. For example, on our tractors for means of transportation, we are using mostly cameras, sonars, and inertial odometry units, but without radars itself. LiDARs we are not using because these sensors are costly. We have a cost-effective approach. For example, our retrofit model, we named them as a retrofit model. This is models for installation on modern vehicles of different kinds. We have a cost below than 200,000 of Russian rubles. This is about 2.5 thousands of United States dollars. In this price, we could not install any type of LiDAR, so we have open sensors of our purchase.
Okay. And what kind of main problems now you see you have to solve? What is?
No problems with high frequency interference because now we consistently could not use 4G or 5G high frequency spectra. We could not almost use in the most location in the territory of Russian Federation for GPS navigation. This is most limited this field of civilian unmanned transport in the territory of our country. So we may try to mitigate and battle with this limitation with our own inertial and other types of telecommunication subsystems.
Okay. Okay, people, please, other questions? No other questions. Okay,
Thank you.
let us thank our presenter.
Thank you very much.
So we are going to election. I would like to introduce Professor Mindley Fu. He is our colleague from Zhejiang University of Technology in the Zhejiang province of China. I would like to say that he was born in 1981, and currently he serves as the director of the Department of Artificial Intelligence at the College of Information Engineering of Zhejiang University of Technology, and is the deputy director of Zhejiang International Science and Technology Collaboration Base for Human-Machine Collaboration Technology. So in 2017, he was selected as a young and middle-aged discipline leader in higher education institutions in Zhejiang province of China. He has won many awards, for example, the Excellent Achievement Award for Scientific Research in Higher Education Institution from the Chinese Ministry of Education, the Zhejiang Provincial Technology Invention Award, and the Zhejiang Provincial Science and Technology Award for the Zhejiang Provincial People's Government. So he has published many journal articles in more than 30 journal articles in Q1, Guangxi, and also many conference papers. So please have a talk.
First, I would like to thank you for the organization of Advocacy. I think I want to thank Alexei for inviting me to deliver this speech. And I also wanted to express my gratitude to Professor Alexander Tuskov. Actually, we have recognized each other more than 9 years. So here I saw many friends and distinguished leaders. So here I want to deliver my speech about intelligent inspection robotic system driven by multimodal large models. Here I want to briefly introduce my universities. I come from Zhejiang University of Technology. This is the first university co-established by the Ministry of Education of China and the Zhejiang province government. And you know that in China we have more than 3,000 universities. And our universities are ranked about 60 to 70. So we are at a very fast speed race to establish a high quality university in China. So here I want to introduce my laboratory. All our works was done by very good teams and very good laboratories. And our goals is not just publishing papers. We want to get the real need from the companies and make and solve their problems. And at last, we want to transfer our technology into the real products. So you can see that in these presentations, I want to show a real examination how we make this. We have two main laboratories. One is Engineering Center of Ministry of Education. Actually, in Chinese, it means Intelligent Perception and Systems. And we also have provincial key laboratories. It is also studied intelligent perception and control for complex systems. And with the support of the platforms, we have huge groups. My groups, we have more than 100 members, so we can make a real big projects. And besides these projects, we have also got some other laboratories. We have other platforms. I want to emphasize that this middle one is human and robotics collaboration base. This base was co-established by my university and Institute of Informatics (UIP). So here I want to say that I repeat it. We have collaborated for more than 9 years. So now we got this result. Okay, let's show why we want to do these projects. You know that in the beginning of 2025, this year, you know that there was big event happening in Hangzhou. We are come from Hangzhou, and everyone knows that Alibaba. Actually, the base of Alibaba is located in Hangzhou. Actually, in the beginning of this year, we have big events. We called it six little dragons companies. These companies, they developed different kinds of artificial intelligent products. Some product is all this, we call it robotic dogs, or quarter dog robotics. And some developed brain machine control devices. And some developed very good 3D games. You know, there's a Black Wuhong. Black Wuhong is very famous, actually. So in Hangzhou, now they have another name. They call it the Silicon Valley of China. So here we got a very good tactics here and very good support from the government. So that's why we want to make this development. You see that these scenarios is just come from all universities. Actually, beside all universities, we also get the requirement from the large tourism area and industry parks and ports and also large warehouses and even, you know, Hangzhou Xiaoshan Airport. You know that for the airport, what they are afraid of? They are not afraid of the weathers. They are afraid of birds because we have a very large airport. and many birds leading near the walls. So the birds is very dangerous for the flight, landing, takeoff. So why we want to study these birds? So they have this real requirement. Take this as an example. We got our university as a training scenarios. First, you can see that we have some violation rules in OLX. You know that in university, if a student or teachers violate the rules, it will be dangerous on fires and disasters. And also, you know that in China we have a lot of mobile bags. But so mobile bags you must get charged by in time. So some people do not use regular driving devices. They use this one. And also they have some open water management. For this kind of management, you cannot just rely on the fixed monitoring cameras because there are some blind area. So we developed these patrol inspections. We use Cobra dogs, and we also developed navigation systems, and we also developed large models. How we do this? I want to solve an overview about this. First, we developed inspection systems. These systems has such functions. Usually, they have devices proficiency. We use fast subwrite and also leaky data, and also we can make a task distribution along these platforms, and we can make the data real display by these devices. And also we also study some multi-emigrate platforms. Our first speaker, Professor did become a he studied automobile navigation. Actually, we have many senior studies. Here we study multi-sensor integration for the air and ground combinations. And we, in our group, we have really good research foundation for the multi-sensor field algorithms. And thus we developed a deploy or training our system in a multi-mode large models in the cluster GPU platforms in my colleagues. So this is an overview. And then I want to share the 4 research conditions. The first is you must so this arts global consistent correlation precision pressure for keep your linears and then system based on multi-sensor fields. Actually, it is a very complex products because for the real environment, we have many scenarios you never be set for. And so we want to do is that we should make a policy update process under communication restriction for the drone superior and UV computer. And then we make a very complex fueling operations use a bigger multi-page reinforcement frameworks to basic this. So we proposed a collaborator coverage method for air-ground heterogeneous multi-bagend built on this reinforcement systems learning method. And we realized the efficient collaboration and global coverage optimization of UAV and UTP. Let's see here some demonstrations. You see that we have a UAP and also a copter box here. The UAV will provide much more good viewers, and they can find some suspected objects, and then they can send back the transportation to other dogs. The dogs will be there to track if it will happen. So here we make and software networks. We use a multi-machine collaborative networking, and we also make the environmental perception, object detection, and many UAV and DUDE. They can collaborate and exchange information between each others. And here we make a lot of tests. See in our university campus. And we make this airborne coordination and local coverage. And it can provide the 3D inspection networks. You can see this the view. This is the view of this corridors. And we can get the first view of the day produced just by two our systems. And you can see these are the real movie alternatives for the corridor locks. We try to solve global constant operation precision method for heterogeneous unmanned system based on multi-sensor. Yes, this is also very a huge project. We use different kind of systems. We can have EGE, MDocs, and UAV, and also we developed MU and also for LIDAR and RTK. And I want to mention that of our team, we developed this kind of RTK board, but all by ourselves. And we also selling this kind of product to several companies we provided our technology. And here we want to solve these problems. The first one is GMU and MU external reference collaborations. The second one is FAST, recommend for collaborating system with MU and LIDAR tracking systems. And both of the last multi-source theories of geography bears optimal. This method was proposed and optimized by our team. So here you can see some demonstrations. Here we need to do this. The first one is that we use this e-build maps and sensor theories for this by this two kind of sensors and also the platforms. And with the UAVs, we got the cameras across the platforms. And for UGVs, we got many sensors. You can see that in our systems, we run RTK and laser slams and plus VIO is vision and integrated odometry tying coupling systems. And all these devices and components are developed by China itself. So here we can get a very good, very steady device here. And then here we can see the core systems. Yeah, core systems. Systems. This is a view. This is the view of the first view. And all this is precision strategies. And we can decoy our task here and some mirror takers. Here we have large models. I will repeat later. And here this is our systems. We test the different area. Indoor and outdoors. Even for indoors, we cannot use the RDK. So we must use the LIDAR and TIROTs. For outdoors, we can use this RTK. So this is our devices developed by our team. And our RTK positioning is actually very, very high here. You can see that our positioning is for the plant, bay one, is 0.8 centimeters. So it is a higher positioning operations. And also we selling this kind of product to different companies. And also to part 3, then we developed these models. Why we do this? Because you know that both UAV, UGV, and also this mobile offload driving repair class, they can treat them as a platform for collecting stickers. But how to analyze the stickers? How to configure your rules and your knowledge into these systems. So we must rely on these audio models. Here we develop multiple perception layers. We get data from drones and robots, get camera images, terminal images, video streams, and also user instructions. And we use the Qianwen. Qianwen actually is a large model interface developed by Alibaba, and it is open source. We use the two kind of villains. The first villain is the Qianwen 3. It can develop the interaction between language and NLP, natural language processing. And for human behavior, we can use it as a video and the mark model method to help us. And then we used a large model plugin toolbox because actually there are team to develop laws. We are not looking to really develop these large models, but we can get a really good plugin boss. And I can get this technique support from the copy from Hangzhou immediate because we have many partners in different countries. If I have questions, I have technical problems, I just call the computer to solve it for us. So here, we make MCP variables. You know that for the traditional inspection systems, you just collect data and they can tell you it is good or wrong. But you lack the ability to really solve these problems. So we use MCP interactive layers. Yes, and over here we also developed knowledge with the searching layers. For example, if you want to use this inspection systems in industrial area, you can call me what kind of rules you want to replace, and then I can enter code your rules to develop this. If you want to use this for detecting assaults or a large profiling algorithm, you just tell me your rules. You can give all more document your data, and we will use the training for training. So here we can update this knowledge, and also you can retrieve these topics, and then we can use MCP tools or bake.
This week of mine.
Okay, thank you. So this is part 2. For part 3, we want to show that with the help of large models, it really helps us. You can see that we get image from cameras, different cameras, and also then we get a few turning models using DeFi. It's a Llama factory, and also we have output structure output division. For this one, and we can we use this data in our intelligent matching emergency knowledge systems. And for these systems, you can see that if it find some images or signals, the smart models can just recognize it for you automatically. And they can also recognize all the records. So here we use knowledge-based inductions. And then we use MCP. You have to indicate that if our system found there are some dangers or disasters, they can just directly calling the people who in charge this business, or they can send some message. They are directly to you. Use WeChat. You know that in China we use WeChat. Everyone uses WeChat. Here, just send this message to your WeChat. And here we want to show these demonstrations. This is the battery safety management. You can see that the system will promote the interface and the record and close with waiting for person to handle. And also the system will push information in apps and in eTalk and through MCP purpose. And also if there are some dangers, the system will directly calling the alarm number to the nearest security person. Yeah, this is WeChat. The last part is our intelligent human computer interaction technology. We want to mention that we developed this inspection is not want to replace people. If we just want to make a robot to just replace the people will lose their jobs. So our technique will not decommode working. So why we going to do this? We want to make their less their burdens. So here, actually, we use the MR equipment. This MR equipment is developed by Meta and use the software Unity. And here, then we develop this and we got MR equipment for remote operations. So our keyboard just sit here in office with very good air conditioner. He not needed to really but you know that in Hangzhou is very hot here. There. Here is temperature is very cool. Actually, Hangzhou, I think the temperature now is still 35 or 36 during in summer. So it is not friendly to people who really work outdoors. So you just sit in your office with your air conditioner. You use this MR equipment. All the decors will transmit to your screens, and also the exhaust and the first billions. So here you can see that we use the control and also you can use controller to control this robotics and also the dots. So this system introduce dynamic focus control technology, enable flexible switching or control between multiple roles via MR headsets and combining with MR visualization of AI perceptions. You can see we demonstrate here. This is VR amplification, and we use drones, and this is a vision provided by drones and goggles. Here our student here use this one. This is a vision of MR inspections. Here the student here control these robots and also they can control the goggles. And the multi-modal life models will help people to make decisions. You know that we talked with some ahead or khaki persons from companies. If they recruit a new person, he has a little insecurities. So you must got very experienced people to keep it. Show your parents. But now with the help of large models, all this experience is now written in our database to the knowledge. Yeah. So for a new person, you just use MR will tell you what you should do for next. How do you deal with your task? Here. So, okay. Just I want to say that it is not the end of the research. We just, I think we just solve some technical problems, but we must focus in real engineering practice. So the first stage is that we must test our systems in different scenarios. We test our equipment not only in universities, but also some industry parks. And also we collaborate with Unitree. Unitree is in Hangzhou, is a very famous company to produce the cultural dogs. Actually, the products of Unitree is the #1 in the world for cultural dogs. And also we have a partner, means deep robotics. So we are partners. We use different kind of models and use different drones to test our techniques to find the problems. And also, we have here partners. So we must test it, and we must try to apply our techniques and systems in their need. And our partners here, China Mobile, Hangzhou, and here is the Emergency Management Science Institute in Zhejiang. They in charge of all the industry production for detecting and for management. And also we have Unitree, whole chat, and we have Beidou navigation. Yeah, this and some partners. Yeah, we collaborate with that. And also we tried to use our system in state brief and insiders and provision groups. Yeah, to be different inspections. And also we try to make a technical transformation from different ways. Here we collaborate with companies, and we also give RSV, and I also attend different launch, especially in Shanghai and in Hangzhou, in big cities. And the people here will show your systems, and they will have questions, and then it will inspire you how to solve, how to improve your techniques. It's very helpful. So here is would be how that. So this is my presentations. I introduced the intelligent expression systems and show how our group do here in our studies. Thank you for your attention.
Okay. Thank you very much, Professor, for your very simplification with example of questions. Okay. Hey, colleagues, please, any questions? Okay. Yeah, please.
Thank you very much for your nice presentation, first of all. I think I'm bold enough, please. Because they are very rewarding spirit to you achieve with this began. Okay, the question is about the training of large neural networks. So I can imagine on one side it's very simple, straightforward approach when I have several neural networks which were just embeddings. And of course they should be synchronized in time and space and everything else. But in Forge, and just breaking huge neural network, multi-dimensional, like, yeah, I must give you the sketchy, no. So that's another approach. And so the question is about what is the border between that two approaches, where we should follow the first one, very straightforward, very simple, separated sticks, and then join together, and the opposite one, when we do it all together because we need to synchronize our day on our working days.
Okay, your question is very important because you know that for large language models, it actually is, if you're training these systems, you must be very diverse, very rich. So here, so common universities, even in Japan University, they cannot train these young models selected. Now we just use these arbitrary models. It's equivalent. For example, the lab models we used in Shenwen, actually we just used the 32B, and it was a full winner with about 7,032B. So here we use these arbitrary models in one, and we just use very simple, just 8 GPU A binary in that bird. So for training this one. So we did not determine Mark to train large models. We just use these models. They open source demo models directly and training with our deckers. And I want to mention that for training the large language models, you should not just emphasize the size of the data. You must emphasize the quality of the data. If you get the very good quality, even just 30,000 cases, that's okay. So you will not be like a lot of takers. It will compute the models. That's that.
Okay, thank you very much, Professor Vamite.
CTP from large language models to large visual language at the bonus so so it can be also practice where they work as a large visual language models.
But you better you by your practice
Oh, so how did it?
Okay. Actually, I want to say that our team actually belong to a department for complex system perception and control. Actually, we are not coming from computer science. So your question is how we use these models for vision and language models. Yeah, we just collect data. Just collect data. Use the camera on the drones and the quarter dogs. Yeah, and we got about 1,000 images, and we use these images to retrieve these Sherman VL models. So it's really cool. Actually, I think these open source models, some brilliant people training these models. We just declare our data in this models, use there, because it's so different. And we can load all the data. And we use the API, we deploy this in our cluster computers. And we just use API to just give the data, and they recognize what this meaning. And if there's something wrong, we get more data and train this. So it's really not a very difficult for us.
Any other questions?
Okay, please.
Good morning. Thank you for your presentation. Could you please provide more details about open water management? Like what is the purpose of this, and how exactly these robotic dogs help? Thank you.
Okay. Okay. I want to give you an explanations why we do this one. You know that in China we have many large urban areas, such as there was a small city we called Hengdian. Actually, in this area, a lot of Chinese films and also TV shows actually filmed there. Actually, you know, in this place, they just reviewed a civilian city in Beijing. Actually, it's large, very large. So people here, you know, in summer, in winter, is not others. People here they not really careful for inspections. So we use the cultural dogs, and the manager of this tourism group, they will tell us what kind of site, what kind of point you must be behind it. This will be some neighbors or some embarrassing happen before. So we will make our quarter dogs to just run there and to check if something well or not, and then contact. So for some fun area, if the quarter dog cannot go there, then we set drones go there. So sometimes we just drones, sometimes just dogs, and sometimes they will go together out. So I think this inspection system will make the burden of these people much not easier, and they will not require very high service. Yes.
Is there other questions? Okay.
Thank you very much for your opportunity. A question about knowledge base software. You have no knowledge base, and there was utilization. Is it utilization of patterns today? And have your which model you have to represent?
Nice. Okay. Okay. For your questions, on to another examinations. We collaborate. Let's say that some emergency management department or laboratories. They send us a lot of official files, such as anti-fire regulations. Some rules should be obeyed by this kind of leaders before. They just say this, sell us a lot of documents, and they also sell us some report. For this report, this report is a formal report produced by some expert. they personally inspect the different kind of area and they use and write some words. And we got these speakers and we got these rules. And we put these rules in the you should say that in chairman models, team models, and train it. And we got real data. We train it use vision and language models. And then in our database, they will just make a retrieval the rules and compare with the result. If the result is against the rules, then we will be open some balance. This is will be common.
Other question, please? Okay, please.
Tell me please how you use the SLAM navigation in outdoor.
Our transition.
SLAM navigation, how to use? SLAM.
SLAM. Okay. We use the open source SLAM delivered by Hong Kong Technical Universities. It's a very like some I can't remember the names, but you can it's very famous one, open source SLAM. We use this layer of the different SLAMs, but what we have done is to make safer configurations with RTK and SLAMs. Yeah, we make built-in algorithms to this. So we are not just developed this like for legal sense. It actually is another very huge engineering progress. Yeah.
It's combined.
Yeah. Yes.
Thank you.
Okay, very short, couple of very short questions. With humanoid robots, you don't have any experience, or you plan to work, or this is not your area. Is humanoids robots. Okay.
For human robotics, everyone is very interested in this kind of robotics. Actually, in our laboratory, we really have some favorite robotics. I want to know that if you have noticed the news in August that in Beijing, the first just like a sports meeting for humanoid robotics. Yeah, you can maybe find some videos, do very robotic with and jump. Yeah, but now you know that humanoid robotics are not directly put into real industry scenarios. Why is that? It is also very newly verified. So what we can do this first? We want to make this humanoid robotics just like a receipt, perceived we receiving people. For example, if you go to airport, you are a VIP. You go to your rooms, and then the humanoid robotics will go there. Hello, what do you want? Oh, how far the flight to this Israel? Isn't will make the airplane company will accept for high tech people. This is also actually in China most scenarios just need this figures. But you in real industry development, I see that Zeek, you know the Zeek is the brand for Chinese mobile cars. Yeah, in their industries lines, humanoid robotics now use the two major assembly. If a humanoid robot is a two or robotics is handling assembly, yes, to producing these parts. But I can't really go there industry wise and not a lot. So I think maybe in the future we can do the same things. You know that in China we have some factories who produce this some like solar pans. Yes, and in their cost, I think there are some multiple jobs can be done by the humanoid robotics. For example, the robotics can make assembly. They can deliver some wafers from this one to another one. I think in the future this is
additional questions. When you just told us about the visual perception system and they using this multimodal large language model. So it means that your your robot research system is it? It is not able to perform his functions. Not communicating with the last, right? So it local no operation, so it dropped the line.
Yeah, very good. So we have, we have another solutions, such as I want to say that we performing a product to inspection the nuclear stations. So in this area, we cannot use 5G or Wi-Fi gear in this. So we deployed small models, not large models, smaller models, even just like we thought you use the media, JSON, or we used in China we have also see the force. Yeah, we devices before edge computing. Yeah, for the devices, label products, and then we store our old data, and then when the dog come back, we can processing his data.
Okay. Anyway, are there any other questions? No questions, or let them very much the interesting dedication. Thank you very much. Okay. So I give the floor to Alexei Lewandowski. Please, Alexei, for the.
Thank you, dear Chairman. Actually, so now it's time for a pleasant part of our morning session. And by the way, so each plenary speaker will be present with our small presence. Can you, Professor Neve, also for Doki, Ibushiki also. So, but I think later you'll enjoy it. And before morning coffee, we actually have to do one or more very important things. And currently, I would like to call our General Director of the United Institute of Informatics, Problems of the Nation and Science of Belarus, Dr. Sergei Rubrikov, please start on the stage. And why the reason why I call him. In recognition of the long-standing and fruitful collaboration with Zhejiang University and Professor Lindley, we would like to award you with a Jubilee Medal of our institutions. Please step to the stage, and now General Director will give Jubilee Medal in a long term of cooperation. Thank you, Professor. I hope that it will be next part for our joint collaboration. Fully outstanding. Okay, thank you. And this is not the end of the session, Professor. I would like not to go to this place, because actually, so now we are coming to the official dedication ceremony of the signing of our joint laboratory between China and Belarus, and all parts of this laboratory are welcomed to step on the stage. So. Again, Director of the Department of Artificial Intelligence at the College of Information Engineering, Zhejiang University of Technologies, and Deputy Director of the Zhejiang International Science and Technology Cooperation Base for Human-Machine Collaboration Technology, Professor Minglei Fu. Again, please, step on the stage. And if it's possible, if you do not mind, please go to the microphone and tell some welcome words about this laboratory. I mean, which you will sign and open it for today. Yes. Okay.
Okay. Thank you very much. And now in September we got a very good news that actually it's over a joint laboratory between China and the Russian who studied the evolved alligator cabinet technology with the baskets by the Ministry of Science and Technology of China. Actually, it's very to do with in the national collaboration cabinets. Actually, it is the first time China and the Russian try to make such lotteries, and in Russia and last year Russia, and the government just want to select 50 only 50 lotteries. So China and the Russia. So actually, before we never saw capital we can prove it. But why is it proved? I think because the support of Professor Cosco, Oli, and creative, and some leaders. And we had long years, more than 9 years collaborations, and we easily give each other many times. And here we organize give conferences. Also, we have, I think we have drawn the puppies maybe more than in modern. Then, but the key developers every day will do this for us. And our embassy, the working staff in Apple or China here in embassies, and I think the once before the leaders call me that if you want to collaborate with your Russian company partners, you must be there for support and just as your best friend. Yes. So I think we got done this, and now we have this China and European national collaboration authorities, and in the future I think we can will see the artificial intelligence. Some people's fault.
Okay. So, please, Professor, I would like to give you these folders, and he will give these folders to pass to the parties of these laboratories. So, please welcome on the stage the General Director of the United Institute of Informatic Products, Dr. Sabir Olgika. So, please, one folder for. Okay, corresponding member of the National Academy of Sciences of Belarus, Deputy Director of State Scientific and Production Associations, Optics, Electronics and Laser Technologies, Professor Sam Shintayu, please. Again, Dean of the Faculty of Applied Mathematics and Computer Science at the Belarusian State University, Dr. Yuri Arlovich. And so now, please step on the stage. Step on the stage to, yes, to hold your hands to these circles. Yes, please. Yeah. And make a photo. Yes, so it will be very Chinese. One hand to the circle, please. Yes, exactly. And photo. So, 3, 2, 1, signed. Okay, thank you. So now this official ceremony is finished, and nothing else between us and coffee break. Thank you. So now you may enjoy with your coffee. Till the next session, please look at your program.